Go ahead and do this. I'm just going to start at the very middle. So I'm going to say that this is my center. And then if I want to draw a circle with a radius of 2, in some places we have to estimate a little bit. But I know if this is my center, if I just go out to 2 on the right, if I go up to 2 on the y-axis, left to a -2, and then down to the -2, to me, that's kind of the easiest way. It's hard to go out to. You can't go out to in kind of these angles. But certainly the 0, the 90, the 180, and then down here, we could get exactly 2. And then from there, just do your best to be a respectable circle drawer. And that would be a circle with a radius of 2. You could put it anywhere. So if you were creative and for whatever reason you put it over here, as long as what you declare is the center, you move out 2 to the right, 2 above, 2 to the left, 2 below, sketch that in. That would be okay. All right. Just make sure we're 2 units away from the center, wherever your center is at. All right. So with that, number 2, look at that circle, write down what the radius of that would have to be. All right, and Julia, what'd you put? Good. So this is another one. If I ask you kind of where that center is at, here is the center. And we know that's the center because we're 4 units to the right of it, 4 units to the left of it, below it, and above it. So we know we're just 4 in either direction. All right. Again, if we're not 90s, these are a little harder to predict. But as long as I know those 4 are going to be 4 units away, then everything is 4 units away. All right, number 3, same thing. Find the radius of that one. This one now is shifted over a little bit. We're not right at the origin, the 0, 0. All right, Assad, what's our radius for this guy? Good. That one is 3. The center is marked with the dot right here so that you know for sure that's the center. We go out 3 to the right, 3 below, 3 to the left, 3 above it. Tells us our radius is going to be a 3. Okay. Next thing I want you to do. So I now give you this circle. And then if you notice, we have some triangles drawn in here. It may look like 2 triangles. What we really want to do is draw in, just to make sure we understand. I'm going to make this a little darker so that we actually see there's 2 triangles over here, one above, one below the x-axis. And then the same thing down here. It's in red, but it's not really easy to see on your paper because it's not color. And then there's 2 triangles over here, one above and then one below. Okay. What number 4 is asking you to do, the circle to the right has 4 triangles drawn in it. So now hopefully we can see those 4. All right, so here's triangle 1. Don't write this because we're going to write inside of it, but just I'm going to erase this in a minute. Those are our 4 triangles that we currently have. What I want you to do is write an equation that will help you find the radius or the length of r for the triangle with the point -3, 4 on it. Okay, so that is this point right here. We want to use this triangle to write an equation that would allow us to figure out what our radius is. So what this stems to, and we've been seeing this more and more recently, well, we talked about it all year, but a lot recently, is once we identify that this is definitely a right triangle, that we have a horizontal line and a vertical line, this is a right triangle, we can use the Pythagorean theorem. Okay. So if we can use the Pythagorean theorem, that means we need to know 2 of the 3 sides. What I'm going to ask you to find is r. We're trying to find r right there in that triangle, which means I need to know how long the base of this triangle is right here. So if we just look at this base, if I started at 0 and I go left to the -1 and then the -2 and then the -3, we should see that this has a base of 3. So that's how long that bottom segment is. If I then go up and down, how long this is, just count your squares. I go up 1, 2, 3, 4 squares right there. All right. So when it says write an equation that will help you find the length of r for the triangle with the point -3, 4 on the circle, this is just setting up the Pythagorean theorem. So let's set this up. I know the base is 3 squared plus the other side, which is going to be, in this case, the height 4 squared. And then the hypotenuse is your r squared. Continue with that. That's going to give you 9 plus 16 is equal to r squared. And then, and what we're ultimately trying to build to, this step right here is kind of the really important step that we want to recognize patterns as we start moving along. Notice how r squared is going to equal 25. We're not done. We do want that extra step. This is going to be an important step for us to write these equations in a minute, is understanding that r squared is equal to 25. If we look at this blue circle, what would we have known the radius is right at the beginning? Like, we don't necessarily have to do this. If this is my center, what would our radius be? So you just did this in number 2 and 3. Caden, what would this radius be? Yeah, we know this is 5, right? Like, here's 0, 0. We go out 5. We go up 5, left 5, down 5. So our radius is a 5. And then now when I solve this, that equation would also tell us that r, ran out of room, is equal to a 5 from that setup. Okay? Well, go to number 5, and it says, does the equation you use work for the point -3, -4? So now that is giving us this triangle that is down here, because that's where the -3, -4 is at. So let's again label these sides. Doesn't this side right here still have a length of 3? It's the same side that the yellow triangle had. And then if I now go to the blue one, I'm going down 1, 2, 3, 4. So this side has a length of 4. We'll show it one more time, but it should set up the exact same way. One triangle is 3 squared. Other side is 4 squared. And then the radius is your hypotenuse. So that should be your radius squared. So once again, you will get 9 plus 16 equals r squared. It tells you that your r squared is 25. Like the previous problem told us, like Caden told us by just looking at the circle, if we didn't even want to make this as hard as we're making it right now, we would be able to determine that that radius is a 5. So what we want to get out of that, even though these had some different signs there, it still gives us the exact same radius. If we go to now triangles 3 and 4, so now let's go to this other side, and we'll do one of these. I'll do this in red. So let's say we do this red triangle. That's what number 6 is asking you to do, the point 4, 3. The base of this one is 1, 2, 3, 4. And then the height of this one is 3. All right, so now for the third time in a row, this should be pretty obvious. If I went ahead and did now 4 squared plus 3 squared is equal to your radius squared, we get the same exact thing. The order is a little bit different. Now it's 16 plus 9 instead of 9 plus 16. But notice how you will again get r squared is equal to 25. Square root that, and we then know our r is a 5. All right. So number 7, we won't go through all the work, but when we look at this guy, notice how this here gives us a length of 3. This length right here is a length of 4. So we would again get 3 squared plus 4 squared equals your r squared. So the answer to this question is definitely yes. That's going to spit out a radius of 5 again. All right. So right now, just kind of over and over and over again. But what we want to get you to understand is it doesn't matter what quadrant we're in. We're doing the x squared plus the y squared equals your r squared. Okay. Every single time. All right. So number 8, that we knew at the beginning. Caden told us. And then now number 9 is kind of the big one here that we ultimately want to get to. Write an equation for any point x comma y. So when we did it, it didn't matter if it was -3, +4. Didn't matter if they were both negative. If it was a positive x, negative y. Didn't matter what quadrant we were in. The equation ends up being the exact same thing for all of them. Okay? So what we did with every single one of these when we set this up, we did the Pythagorean theorem. So don't write down what I'm initially going to write down. So we just used the Pythagorean theorem, which is normally this: a squared plus b squared equals c squared. And in every one of these, wasn't the hypotenuse in all of those the r? What is the r in this problem? What did we say our radius was? 5. So we're going to replace that with the 5 because we now know what that is. And then every one that we did, what we did is we took this x, and x wasn't that the first term that we were squaring in that Pythagorean theorem. When we came over here, here was the x value of 4, 4. Notice how that was the first term right here. So in every single one of these, the a was whatever the x coordinate was in our point. And then the b was a 4, the -4, just the lengths of those. What the b was in every single one of those was whatever the y coordinate was in that point. So the equation for that graph that we looked up here would always be this right here. The x getting squared plus the y getting squared equals your radius squared. And again, it's nothing more than an extension of the Pythagorean theorem, where the radius was your hypotenuse, the x is your a, and then the b is your y. Okay? All right, so then the next one, the standard form of an equation of a circle centered at 0, 0. So every single one of these that we've looked at, this one has a center at 0, 0. The 3 that we have up here, 0, 0, 0, 0, 0, 0. I did draw one that was further off, but the 3 up here that are centered at 0, 0 is always going to be this. It's going to be your x squared plus your y squared. Again, nothing more than the Pythagorean theorem, with x as the a, y as the b. And then not every single circle will have a radius of 5, but didn't we right here have your radius squared? So we're over here on the right-hand side. It is always set equal to whatever your radius is squared. So when we start, and this is what we're going to do 10, 11, and 12, if I ask you to write the equation of a circle, as long as it is centered at 0, 0, you're doing x squared plus y squared equals whatever the radius is squared. Okay? So 10, 11, and 12. So if we go to that, here is the general formula. If we're centered at 0, 0, which this is, it is x squared plus y squared equals your radius squared. So really all we need to be able to identify, if we know that equation, is what the radius of this circle is. So the same first 3 questions that I gave you at the top of the paper, I'm going to erase this r. And Assad, what is the radius of this circle? Good. That is 6. All right. So this is totally fine. What will very often happen is instead of writing this as 6 squared, so if you leave this as 6 squared, 100% correct, it would not get marked wrong. But a lot of times this will get written as 36. And you would then understand then that the radius has to be 6 because this expression is the radius squared. Okay. So for number 11, this is x squared. We're centered at the origin. It is a circle. X squared plus y squared equals your radius squared. We look at that circle. It's centered at 0, 0. Pretty clearly, our radius is a 1. You can leave that. 100% correct. We could also just say that 1 squared is 1. So if we actually got rid of the squared, all right, this would also be the way that is written. All right, do 12 real quick. Write that. All right, and Ella, what do you got? Good. X squared plus y squared equals the radius squared. So that's why she said 2 squared. If you wanted to, you could then write this as 4. All right. All right. Don't flip that just yet. I want to add a couple problems down here. So now what I want you to tell me. So let's say I gave you x squared plus y squared equals 100. So write that down. And then underneath that, tell me what the radius would be. All right, Jason, what would the radius have to be? Good. So this is simplified. You just have to understand that is the 10 getting squared. That's how we got that 100. If I give you x squared plus y squared equals, we'll keep these nice for right now, 64. My radius then, Jada, would be what? Good. Our radius is 8. Okay, so just know it could be simplified. You could use the squared. If it's already simplified, no, we actually want the square root of this to figure out what our radius would be. Okay. The whole first page, just keep in mind, those are all centered at 0, 0. The center of every circle on this page was drawn in at 0, 0. All right, next page. Do number 13. Sketch a circle that's now centered at 1, comma 2 and has a radius of 2. Okay, nothing crazy. We should all be able to plot a point. So you go to the point 1, comma 2. And then if our radius is a 2, the one that we can get accurately is 2 to the right, 2 above, 2 to the left, and then 2 below. And then as best you can, sketch in a circle connecting those 4 dots. Notice again, though, we're not centered at 0, 0 anymore. That's going to change our equation here momentarily. All right, 14. Do that one. Find the center and radius of that circle. So tell me the center and then the radius. All right, Sarah, what did you find to be the center of that circle?
The center would be 5. No, no, no. Would it be that?
It would be that. Yeah.
-1.
Good. Yeah, 5, -1. So this is the center right here. If we were to kind of look at that, and you can test it. It's a little bit of guessing, but eventually when you put that dot, it should be kind of appealing to the eye. It should appear in the middle, but then you could test it. You'd be 1, 2, 3 to the right, 1, 2, 3 above, 1, 2, 3 to the left. And while you're doing that, confirming that that is in fact the center, you're also finding that the radius is 3. All right. Okay, last one. Sketch in now. This is the center of the circle, and we want a radius of 5. And then we'll kind of get into these equations. Okay, largely the same as 13. You want to plot the center first, so that's the point -3, 4. So -3, comma 4. And then if that is your center, we want to move 5 units to the right, left, above it, below it. So 1, 2, 3, 4, 5. 2, 3, 4, 5. 5. All right, connect those as best you can in a way that makes it looks like a reasonable circle. All right, and that should be our graph. Okay. Notice these are now not centered at 0, 0. So that's kind of the whole point of the back page. The center is definitely not at the origin. It's off in one of the quadrants. All right. So now we go to these. Notice how the blue one, the one that is solid, at least solid, yours is not going to be blue. The blue center is still 0, 0. Obviously, the red one, the dotted one on your paper is not 0, 0. So the first thing in number 16, it says compare the solid and the dashed circles. All right, write down how they are similar. There should be one very clear fact about these that make them similar. So write that down. All right. And Joe L, how are they similar? Good. They have the same radius. All right. What is that radius, Joe? Good. So if we're at the center, this is easy. Go right 4, left 4, down 4. If we found the center here, this would be 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right. So they're the same because they have the same radius. All right. Go to 17 then, write down what is obviously different about them. All right. And what'd you put, Julia? Good. They don't have the same center. So I'll shorten that. We'll just say they have a different center. All right. 18 then. Write down the center of the dashed circle. So go find that, put your dot there, write down the center of that. All right. And Armando, what did you say the center of that was? Good. So here's the point 3, comma 2. So that is the center of this. So now here's what we want to kind of eventually be able to do. How is the center of the dashed circle, so this guy right here, related to its equation? So in each of these, we have the equation for the first one. So these are the ones that we did on the front page. This blue one is centered at the origin. The radius was 4, so we could have written that equation as just x squared plus y squared equals your radius squared. Okay, and the radius in this case was a 4. When we now look at these equations, look at what the equation of this red one was. Notice how we have an x minus a 3 instead of an x squared. And then we have an x minus a 2 instead of a regular old y. And then it says, how is the center of this guy? So we said this is the center related to the equation of the circle. So what I want you to do, write this down first. So this is the equation when we're centered at the origin. All right, so this is the blue circle. The way we get that second equation is not a coincidence that it is a pattern with the center point here. So instead of just a regular old x, notice how the center was a 3. The way that equation got written was x minus a 3. The reason we are doing a minus a 3 is because that is the x coordinate of the center of your circle. When we go to the y equation for this guy was y minus a 2. The reason we are picking a 2 is because that was the y coordinate for the center of that circle. The radius stays the same. It is still your radius squared. All right, so the 16 is the same in both of them. That is not going to change when we write these equations. All right, so real quick, number 20, do 20 real quick. All right, Omar, what was the center of this guy? Good. So negative 2 comma 3. And what was our radius, Omar? All right, so now let's look at this equation. So what I want you to do is, we'll try to squeeze this right in here. Instead of doing the x squared like we did on the front page, now notice where that equation came from. We're still doing the radius squared, so the 25 comes from the r getting squared. Now look at your x coordinate. Your x coordinate was a negative 2, but when we wrote the equation, notice how it is now an x plus a 2. When we had a y coordinate of a positive 3, notice how when we wrote the equation, it's going to be y minus a 3. So what we want to kind of start to recognize, when the center was both positive, positive 3, positive 2, when we wrote the equation, notice how it looks like a negative 3 and a negative 2. kind of the opposite sign. When we go to this next one, the center was a negative 2 for x. But in the equation, notice how it's a positive 2. The y coordinate was a positive 3. When we write the equation, it's going to be a negative 3. So we can start to write these equations here in a minute. All right. 21. Do all three things now. So graph the circle. It has a center at this, and it has a radius at 3, and then now write that equation. See if we're understanding how we can write that equation. Okay, circle, I would hope we can all do. That should have been easy when we did the first one on the front page. But now we want to write the equation for this. Okay. Don't write it down. I'm going to write on the front page when we were centered at 0, 0, we just said it's x squared plus y squared equals your radius squared. Super easy. This clearly is not centered at the origin anymore. So that now changes this left-hand side, but the right-hand side would now be the same. It's still going to be your radius squared. So you can pick 3 squared or you can pick the 9. All right, left-hand side. Anybody confident in what they got? Omar, what do you got?
X minus 1 squared and then plus x plus 3 squared.
You're really, 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 really warm. Say this one again.
X plus 3.
Except what? So let's go back here. The second one should be a y. Yeah, but then other than that, you're good. So then y plus 3 squared. Why did you pick a minus a 1 here, Omar?
Because the x is a positive, so you
Good. If this was a positive 1 originally, when we write our equation, you're going to write it as a minus a 1. Same thought process you use with the negative 3. The y coordinate was a negative 3. When we write the equation, it becomes a positive 3. So that is the equation of that circle. Okay. Last one. You don't have to draw it. Write in the equation of number 22. All right. Anybody got that one? Assad, what do you have, bub?
X minus 2 squared plus y minus 4 squared equals,
Okay. We agree, disagree. I like a lot of that, Assad. What's the center, Assad? Give me the center. What point is that?
negative 2, negative 4.
Good. So what we want to recognize here, so come over here, Assad, where I'm circling over here. See how this x was a positive 1? When we wrote the equation, didn't it end up being a minus a 1? This y was a negative 3. When we wrote the equation, it became y plus a 3. So whatever the original sign is, doesn't it get switched when we wrote that equation? So when we write this, this would be what? Good. So we want to write that as x plus a2. And do we need to change that one? Because this was a negative 4. So this should become a positive 4. Okay. So this should be your equation. And you could do 4 squared as well. Either 16 or that 4 squared. Okay. All right. So then, as a wrap, real quick. So here is what we would consider the standard form for an equation centered at HK. Again, if it's centered at 0, 0, it actually would work still. But if it's centered at 0, 0, which is x squared plus y squared equals your radius squared. But now what happens is if this is our h, then whatever that value is, if you consider this kind of a positive h, notice how there's not a negative sign in front of it. So that positive h, you're going to put a minus sign in front of. And then same over here, you're going to do y minus a k. Understand why that works. Let's go back to the one that Omar gave us here. If this was a positive 1, I would be slotting a positive 1 right here. That gives us x minus a 1. If my k was negative, like it was right here, this negative 3, if I went down to my equation and I replace this k with a negative 3, notice how you get y minus a negative 3, and then that's what turns that into a positive 3 like it's supposed to be. Okay, and then it is always equal to your radius squared. All right. Okay, good with that. All right, tomorrow I want to give you some more. We're going to add a little bit to it. Then you'll get the homework. You'll be able to kind of do that in class. And then I want to take now this last 10 minutes. I can give you the quiz back. So you can have the quiz for 10 minutes. You can look it over. If there's any questions, you're not sure why you missed something, let us know. We had a bunch of people not here on Friday. So we're going to collect those back. You're not going to be able to keep those. But if it is a grade that you are not happy with, then you can retake it starting Thursday. I need to actually make a new form, and I'm not going to guarantee I have that done by tomorrow. So any intervention day, Thursday, Friday, or next week, sign up to see Mr. Kubowitz or I, and then you can retake it if you think you want to try to get your points back. Okay? So we'll do that now.